Hi, I'm Elliot Veers, and in this video I am going to be testing the power consumption of a 4-foot fluorescent fitting, and the bulb is 36 watts and it's an old style fitting with a magnetic ballast inside. Just to give you a bit of info on why I've got this light, essentially when I ordered the lights for my shed behind me, what you can probably see, they should have both come with electronic ballast, but one of the lights they sent me, this one here, came with a magnetic ballast, and when they sent me the replacement, they essentially said keep this one as they didn't want it back. And if you're wondering why I've got one with electronic ballast in, it's A, for efficiency reasons, but also B, for filming reasons, so that I can film in here without the 50 Hz refresh rate interfering with the frame rate of my camcorder, although typically I film either at 25 or 50 frames per second. Anyway, I shall now plug the light in and show you its power consumption as well as the power factor. I shall start with the power factor, and the power factor is 0.93, and essentially what the power factor is the ratio between true power and apparent power. And essentially with inductive loads you've got a thing called reactive power, what's essentially where the device appears to be consuming power, such as the voltage drop and as current consumption, but in reality the power isn't actually doing any of the work. So the apparent power is the true power, what is the power that the device is using to do the work, plus the reactive power, what's the power that is being weighted effectively. So that's a bit about power factor. I'll cover it more in a separate video. And finally, the actual power of the lamp with the ballast is 44.9 watts, and as the lamp warms up that will go up to about 46 watts. So essentially the lamp is 36 watts, the total power consumption when it's warmed up is 46 watts, and that essentially means the ballast inside the lamp is consuming 10 watts or 21% of the fixture's total power. And just to show you how important the power factor correction caps inside these fixtures are, if you note the power factor is currently 0.97, I shall unplug it and I shall remove or disconnect the power factor correction capacitor, and I shall do it right now. The capacitor is right over there, this thing here. Now these days I wouldn't really recommend you get a fitting with a magnetic ballast inside, only for the reason that they're less efficient than the ones with electronic ballasts, as well as they can be heavier, as well as obviously with electronic ballast you've got the advantage that also you don't have any sort of weird frame rate effect things going on with camcorders that aren't to nature mains frequency, such as, you know, 50 Hz is okay when filming at 25 or 50 frames per second because it's in sync. If I filmed at 30 frames per second with a 50 Hz ballast, you would get a flickering effect, and that's why I went for electronic ballast, what operate in the region of tens of kilohertz. Okay, I've now disconnected the power factor correction capacitor, and I shall put the bulb back in, and once again I shall plug it in, and I shall first test the power factor, and you'll see the power factor hovers around 0.39, and essentially what that means is where before it was 0.97, was it? Say it was 0.97, it essentially now means that roughly half of the power being used by this lamp is essentially being wasted in reactive power. Whether that results in a drop in light output or an increase in the heat in the ballast, I don't know, but it probably essentially just means that, you know, well, it must mean, because if the power isn't going to light the light up and it isn't generating heat, it's just not being utilised. So anyway, that really concludes this video. I'll cover power factor in a separate video, another time because it's quite a lengthy subject. But just to end the video off with, the energy consumption is pretty much the same as you say call it 46 watts, it's 0.1 of a watt away. And yeah, that concludes this video, so can I say thanks for watching, and until next time, goodbye.